So, professionals in any field, after a point, need feedback in order to learn to keep improving, to push themselves, to move beyond their comfort zone. Athletes get to watch themselves on video to sort of hone their technique. Now, school districts around the country, especially in the last 10 years, have been assembling student achievement data, calculating, for instance, value-added models for tracking teacher impacts on kids. And as important as that is, and as useful as that is,
it's not enough. We designed the Measures of Effective Teaching project to try to identify some additional tools beyond just test scores that could be useful for providing feedback for teaching. So the whole point of the project was to fill out the portfolio, not just have student achievement gains, but to have other things. So in the project, we're testing out 5 different instruments for doing classroom observations, some not subject-specific, some subject-specific. We also thought we'd try student surveys, because I'm a college professor. It's ubiquitous in higher education. That's the primary way that we evaluate instruction in higher education. I'm not saying it's always perfect, but we thought, let's try that in K-12, but let's see whether it's valid and reliable. Finally, we are including value-added measures. The other thing that was unique about the project was just its scale. So there were nearly 3,000 teacher volunteers from districts around the country that were willing to come help us in this research. The other thing that's unique about this study is that we're looking at a range of different student outcomes. So we're looking at gains on the state math tests, gains on the state ELA tests, but we had a unique opportunity to look at other student outcomes too. So we had students take the balanced assessment in math, which tests conceptual understanding in math and not just ability to do math operations. In English language arts, kids took an open-ended version of the Stanford 9 reading test. Finally, we also looked at some other student outcomes, like student reported effort. So we asked students, do you agree, disagree? I did my best work in this class all year long. And even just kids' enjoyment from being in a particular teacher's class. So the first step is just defining clear expectations for teachers. Here's the distribution of actual scores across these 7,500 lessons on one of the instruments, the Danielson Framework for Teaching. And in the version of the Framework for Teaching that we used for this study, there were 8 competencies. One thing to notice is that there were very few people either at the unsatisfactory end or the distinguished end on any of the competencies. The second thing to focus on is just ensuring accuracy of observers. The way we handled that in the project was that after people received, I think the average was 27 to 35 hours worth of training on the instruments. It varied by instrument. We showed people videos that had been pre-scored by people who were expert on the particular instrument. A third step is for just monitoring reliability. Well, what we did there was we took a random sample of the videos and we had them scored twice. And we could compare the different scores to tell us something about the amount of reliability. And we had the same teacher, because they taught more than one lesson, we could see how scores varied from lesson to lesson. We could actually even see how scores varied from section to section, because the teachers in the study, if they taught 2 sections of the same course, had video from both sections. So we could see how did scores vary depending on the group of students the teacher was standing in front of. And what we learned in the process was that if we just took one rater score based on one lesson, only about a third, 37% of the variance in the scores from the one observation represented consistent aspects of teachers' practice. The rest was other things. The rest was rater judgment. It was also, importantly, lesson-to-lesson variance. Well, why don't we take a few different, let's observe more than one lesson, and maybe let's get more than one person involved in doing the observations, and let's average them, and then ask how much of the variation in that average represents consistent aspects of a teacher's practice. Now, when we did that, we found that by the time we observed 4 different lessons, each by a different rater, it was then that we got to the point where more than 2/3 of the variance was represented consistent aspects of teachers' practice. It's hard to tell, it's impossible for us to say how many observations you're going to have to do to achieve reasonable levels of reliability, but we can say that it's important to know what kind of reliability you're achieving, and so you could do something very similar to what we did for determining reliability. It's important to verify alignment with outcomes. So the whole point in doing this, let's remember, is to help teachers help students learn more. So if the folks who are getting higher scores on the observation are not necessarily getting larger student achievement gains, at least on average, then the classroom observation is not going to be very useful to achieve that goal. So on the left-hand side are the state tests, in the top state math and the bottom state ELA, and on the right-hand side, on the top is the balanced assessment in math, and on the right at the bottom is Stanford 9 open-ended. So the first thing to notice is the slopes are up. The second thing to notice is not a dramatic difference between them. That, you know, I'm sure in some of them there were differences, but mostly when I looked at that, I saw mostly similarity rather than differences. So each of the instruments had about the same relationship to these outcomes as the others. The third thing to notice was that all of these slopes are flatter on the state ELA tests. So now I want to talk about the power of combining measures. Now, I have a 6-year-old boy, so forgive me for this, using this analogy, dynamic trio. He understands in a really, really profound way that if you're going to have a team of superheroes, they better not all have the same superpowers. These measures are like that too. They have different strengths and weaknesses. It's silly to be thinking about which one is better because there are different dimensions to worry about. So when we were comparing these measures, we did the following thing. We said, okay, let's collect this measure of effective teaching when the teacher was working with one group of students, and then let's see what those measures say about their likely success when they're working with another group of students. So we compare the measures on 3 different criteria. One, just predictive power. So which of these measures, the classroom observation, the student survey, the gains on the state tests, value added, or a combination of the above, were most predictive of which teachers were more likely to have positive student outcomes with another group of kids. The second criterion we used was reliability, and by that I mean lack of volatility. And then the third criterion, which is mostly is just potential at this point, is the potential for diagnostic insight. Which of these measures are more likely to be able to help teachers identify what they need to work on? What did we find? Remember the superpower analogy. So it turns out for value added, or student achievement gains, its superpower is predictive power. So if you're trying to identify which teachers are most likely to have success when working with another group of students, the measure that has the greatest predictive power among these three is value added. Okay, so student survey. One of the surprising things, and this was a surprise for us, so student survey does have medium predictive power, not as high as value added, but substantial. But among the measures we looked at, it was the most reliable. Okay, third, the observation. The superpower for the observation is a potential superpower, and that is this potential for diagnostic insight. Because the observation, because it's based on a trained professional going in to do an observation, if that person is doing it with accuracy and reliability and is well trained, there's a much higher potential that the professional, the teacher will take that feedback and try to work on some things. Next, I just want to talk about the compared to what question, because again, we're gonna see lots of stories in the papers. I'm sure many of you probably already have, of implementation challenges in the first year of Race to the Top, or implementing this classroom observation or anything. And there'll be the story about the teacher of the year, or everybody's favorite teacher at the school that doesn't do well on the observation. And clearly, some of those will have been mistakes. Impossible to know which ones, though, actually, unfortunately. And so, because you can't know for sure which ones, you ought to be asking, okay, on average, do I think that the information we're using now is better than the old information we were using? Master's degrees and experience. Because in the past, compensation and even retention decisions have been based on those two things, master's degrees and experience. And so we just wanted to see, all right, on these various outcomes that we're measuring, how well does this combined measure, combining classroom observations, student survey, and value added, do relative to master's degrees and experience? Now, on the left, we first just look at state math value added. On the right is state ELA. On the state math value added, the way to read that is the darker orange bar says that the top 25% teachers on that combined measure that combines observation, student surveys, and value added gained 4.5 months relative to the average teacher in the study. The bottom quarter, the students assigned to the bottom quarter teachers lost 3.1 months. So the difference between the top and the bottom quartile there was 7.6 months, almost a whole school year. Now the differences were smaller on the state ELA tests. I'll show you the Stanford 9 in a second. Now look, master's degree on top, experience is the second panel there. Small differences, in fact, they're not statistically significant. Right, so what about the other outcomes? Again, larger differences in the bottom than for master's degrees or experience. And in fact, 3 out of those 4 differences were not statistically significant for master's degrees or experience. On the last one, we also just looked at student effort and student attachment to school. Experience, and again, none of those 4 are statistically significant. These 2 at the bottom are statistically significant.